My greetings to Dr. Radzi. I am Rishalini daughter of Sarvanan. Today for our group project, I would like to start by explaining about the problem statement and objective of our project. The topic that we have chosen is the gas sensor. What is the problem statement? According to the latest statistic in Malaysian government, in 2019, total 50,000 of fire breakout and 3 million ringgit of losses due to fire breakout was recorded. The petroleum industry could enhance their safety by using sophisticated gas sensor to detect leakage in their sites. All of these problems that we observe from day to day could be prevented by using a gas sensor network that's powered by the microcontroller. In this study, the gas sensor from the market with the MBED microcontroller could be served as a prototype of implementing the industrial-ready gas sensor in. Next, what is the objective of our project? The objective of this study is to prototype a sensor system powered by the MBED microcontroller and a generic gas sensor MQ3 that is to able to detect the existence of flammable gases in the air, displaying the reading on an LCD display, and finally alert the user, which is the LED on or off, if the gas sensor reading indicates the amount of flammable gases exceeded the safety level.
Assalamualaikum and salam sejahtera. My name is Wan Muhammad Aslam bin Asri and my meeting number is CE1900007. And for this project, I will to explain about the methodology. The first main part what we use is STM32F1036836. It used for we pen what we use for coding. And for the input what we use is MQ4 gas sensor. It will give a signal if detect gas. And the last is a LED. LED is a output what we use for this project. It will give a signal if it detect the gas sensor. And other than that, we also use a jumper wire. That's all from me. Thank you.
My name is Shari and my matrix number is AE190112. I would like to explain about software flowchart. First, we need to open out STM32CubeMX development platform as shown in figure. We need to press access to MCU selector to select the microcontroller model. We have to search the microcontroller series number into the search bar and then select one of the results that is shown in the list. There are two types of microcontroller with the same part number name. It's because the packaging technologies are different. After selecting the microcontroller, we need to configure the pin for the reading analog input for sensor value and digital output for the LED. We will leave the clock configuration and finally give the project name and working directory to proceed to the coding. It concludes the setup part of the microcontroller. After the setup is done, STM32CubeMX will download a bunch of libraries that are required by the specific microcontroller that we are using.
Greetings to Dr. Radzi. My name is Vanessa Armugam. My metric number is AE190128. Today I'm going to explain the methodology part, which is the coding or the development environment. After the embedded code is generated, we need to choose an integrated development environment to write, compile, and debug our code. So we will choosing STM32Cube IDE to program our microcontroller. First, we need to open the STM32Cube IDE and select the project folder that is generated by STM32CubeMX. Then a bunch of folders will be opened and we need to choose the files are generated by STM32MX Cube and they serve as the project boilerplate. Then we simply press the run button at the top of the toolbar menu to compile, flash, and execute our program in our microcontroller. Next, I'm going to explain the sensor value and converting it to human readable figure. The final program is modified based on the template generated by STM32CubeMX, and following paragraphs are following one or more snaps of the code that cover the program that is responsible for setting up general purpose input/output GPIO pins in the program for reading, converting raw sensor value to human readable value. And this is the coding we use. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq bin Syaiful Nazri and I will explain about result and analysis. So the first thing is we wire up the hardware as shown in the figure below. The code is successfully compiled and flashed to the microcontroller. The gas sensor is also working after connecting to the microcontroller. To verify the program, we use a ST-Link dongle version 2 as a debugger to debug the variable value in STM32Cube IDE. Next is, the debugger is showing the value of RS and RO after calibration, and the ppm value it read and convert from the sensor raw value. This one. Then the RS-RO ratio is very close to 10, as in the clean air environment. The ratio of RS and RO will not have drastic change no matter how the ppm of the clean air particle changes, referring to the chart. However, if there is presence of methane or smoke gas particle in the air, to demonstrate, we could use a lighter or a Chinese incense. The value of RS-RO could drop way below 10. For testing purpose, we shot the analog input of the microcontroller with the 3.3 volt pin to give a very high value as to faking the existence of flammable gas. The RS and RO value dropped to 2, and then the ppm value is 993, which is very close as in the datasheet chart. This the chart. This is the figure 2, which is sensitivity characteristic of the MQ2. That's all from me. Thank you.